Good evening, guys. I'm Chris, and welcome back to another episode of Rift Amps. Just working on the chassis layout for this custom build for my customer Ed. So I've printed out my one-to-one size board, but I've mirrored it, obviously because I'm working on the back side of the chassis. And I'm just getting my valve socket locations done roughly where I want them. All right, so that's done. I've marked on where I want the cap cans to go, and when the transformers arrive, I can mark on the size of those and other bits and pieces. But yeah, that's coming on nicely. I'm pretty much done with the board layout now. I mean, the dimensions aren't going to change, but there's a couple of things I might just tweak. Bits and pieces like that, but yeah, we're getting there on that one, so that's good news. The WEM Dominator did the plate resistors. This PCB is falling apart. The minute you wave a soldering iron near it, the traces just start peeling away, so you've got to be really careful. So I've done an overboard repair here, but that's fine. I've managed to fix the crackling. It wasn't actually the plate resistors, annoyingly. It was one of the snubber caps on the anode supply for V1A. That's now fixed. The only thing I've got to do now is this pot is still quite noisy. It's really difficult to get in there to clean it, and I don't want to have to remove it from the board. So I'm working on a solution for that. New output valves are on their way. Then we can just check the bias on it, and we should be good to go on that. But yeah, that's good news. Here is a PR18 for Coda Music that I've just finished burning in. And I want to make a couple more changes before I box it up and ship it out the door. So yeah, quite happy with that one. And I'm still working on the PR1850. I've actually put this to the side for a little bit because I'm waiting on the faceplates to arrive. So until they're here, can't do much with it. But yeah, it's coming on nicely, actually. Right, Q&A time. Diamariv3628, hope I pronounced that correctly. Love the channel, Chris, especially the diagnosing part, as I'm a junior tech and learning as much as I can. Could you show us how to put in the strain relief with that tool? Are there any tricks? I always have problems installing the fatter 3-wire cords into fenders, even with the tool you have. You've got to match the... Yeah, I suspect the issue you're having, is that you're trying to reuse the old strain relief. And if you do that, often it won't work. And what you need to do is get yourself the correct size strain relief for the gauge of mains cable that you're using, and that should go into the hole. Obviously, if it's a vintage amplifier, unless you get customer's permission, I would advise not trying to enlarge the hole. But if it's a modern unit or you do have customer's permission, then sometimes you can just enlarge that hole ever so slightly with a file or whatever, just to ensure you get the correct clearance. So yeah, it can be a bit tricky, but you've got to make sure you use the correct size strain relief for the correct gauge of wire that you're using. And there are many different sizes and different combinations, so you have to just check it, make sure it's right, and you'll be okay. I don't think I did a weather update on Sunday, but here we go. Beautiful sunny skies, glorious weather, mid-July. Might get the deck chair out. Samo303 says, interesting to see you sticking with axial electrolytic caps for the new design. I would have thought that designing it for radial electrolytics would help with future proofing. Would be nice to hear your thoughts on Wednesday. It's a funny old thing, this. We get these comments all the time. Now, many years ago, some areas of industry started moving away from the axial type of electrolytic capacitor. And when we say axial, we mean that the wires run through the chassis, so through the capacitor on an axis like that. So you've got it all the way through, right? Radial capacitors have both wires coming out of one side. Now, when industry started going towards things like PCB design, SMD, you know, those quicker methods of manufacturing stuff, these became easier to use for many reasons, one of which was that for the pick and place machines, they're easier to grab. People started to worry that the axial type would eventually stopped being manufactured as everyone moved away and started using the other type. Now, probably 12 years ago, we did see a slight reduction in the availability of axial caps. Now, I'm going to preface that by saying it started to become more difficult to get the really odd values, you know, the super high values and the super low values in a range of voltages, okay? But the common values, especially ones used in specialist industries like guitar amplifiers, hi-fis, bits and bobs like that, not only have they become more common, as in manufacturers have been producing more of them because, you know, demand has gone up, but also we've got a wider range of manufacturers or people actually making them. So you get more boutique options alongside the more common names and brands and things like that. So it's actually gone the other way. The increase in popularity in radial electrolytics has actually created a market where these things are more popular and more easy to find than ever. So actually, as far as future-proofing goes, I'm not concerned whatsoever. These things, especially in the common values and the common voltages that are always required for guitar amplifiers and hi-fis and bits and pieces like that, are always going to be available. And we've got more and more manufacturers making these things now. So as far as future-proofing is concerned, it's not an issue. It's not to worry about. Don't worry about what people say online. These things ain't going anywhere. One of my subscribers, a lovely chap called Gary in Germany, I think South Germany, has kindly emailed out of the blue his documentation for the output attenuator circuit on the car Mercury. I didn't actually get round to emailing car. It's on my to-do list, but this morning I came in and there was an email from Gary, who's an amp tech in Germany. He used to work on cars, or used to work with somebody who used to work on car amplifiers, and has kindly provided the schematics for the attenuator circuit. And most incredibly is each circuit for each switch position. So you can see exactly what's going on and what parts of the circuit get added in or removed when the switch is in each of its 4 positions, because obviously it's is it a 3-gang wafer switch? I think so. I'll double check. So yeah, so this has literally just come in. I haven't studied it properly, so I will, and I'll go through it and work it all out. But I need to get this video edited and uploaded in time for release. So yeah, but I just wanted to show you. That's the power of the internet. A very nice subscriber has sent this through to me, and hopefully I'll be able to match it up with what's going on in the amplifier and then use it to diagnose why it's not working. SJ Greaves says, I understand how bias affects the dissipation and the operating point of an output valve and why that needs to be in the appropriate range. Good. But how and why does bias affect tone? Does the B plus affect tone, assuming it is based on the same amount of dissipation as for differing B plus? Thanks. I appreciate the spectrum analyzer. I know the effect, but nice to actually see what happens. So we'll start with the latter thing first. The Sunday's video on the spectrum analyzer, incredibly popular. You guys seem to love that, so I'm going to show you more of that in videos to come. Not only am I going to show you the sine wave on the oscilloscopes and things like that, I'll also show you the harmonic content and profile of amplifiers, and especially interesting on the vintage and rare stuff. So yeah, that was popular, so we'll do more of that. Okay, does bias affect tone? I'm going to try and keep this really, really simple for you. I apologise if there are people out there who want a more in-depth answer, who want more detail and understanding, want me to go into this, but that's not what this channel is about. There is yes, bias affects tone, yeah, but it's not always a good thing. It might be, it might go in the wrong direction rather than the right direction. Okay, so it's all down to our ears. Or it's not all down to our ears, but a big part of it is how we perceive volume and perceive tone. As a general rule of thumb, and this is very, this is not a blanket opinion, this is just a tentative answer. The hotter you bias an amplifier, or bias the output stage of an amplifier, the more output it's going to achieve, up to a point. So if you were to pick a random number and bias to, I don't know, 40% of maximum, and then bias to 70%, the 70% output most of the time the 70% bias point will mean the amplifier puts out more output and therefore more volume. And because of the way our ears work, we generally associate things that are louder as things that are sounding better. All right, this is why transparent boost pedals, just by lifting the volume slightly, make everything sound a little bit better, because we want more of it. Everything sounds richer and deeper, etc., etc. Now, I will show at some point on the scope that there is a point of no return, basically, where even though you can make the thing bias hotter and therefore possibly increase the output of the amplifier, you're not adding any more harmonics to the output of the amplifier. Some people prefer their amplifiers biased cooler, because that achieves a certain breakup and distortion and overdrive than others. So it's not a hard and fast rule, but your takeaway from this is, yes, biasing does affect tone. Does that mean it's good tone? No, it doesn't. Does it mean it's bad tone? No, it doesn't. It's a multitude of things that you all take in as one and kind of make a decision at that point. But I can prove to you on the oscilloscope and the spectrum analyzer that if you bias I always bias for power and clarity. So if you set that point and then we just bias hotter, yes, we might get more output from the amplifier, but we might not be getting any more tone or harmonics and things like that. So I hope that makes sense. I'm trying to keep it simple, but it's a really good question. Second part was, does the B plus affect tone? Yes, it does. Yes, we know that different operating points, B plus points, especially on the screen versus the anode, does affect how the amplifier plays and responds, and often sounds. You can change a lot of things that way. So yes, it does all make a difference. And again, I always say this: whether it's a good difference is up to your ears. So there you go. Great question. Thanks for asking. Okay, Reinhardt on the bench. I've just taken the bias measurements as the amplifier currently is, with the 150 ohm resistors in circuit, and this is what we've got. So you've got two valves sharing each resistor. So 6 and 7 share one, and 4 and 5 share the other. Anode to cathode voltage 371, 372, so quite close each side. Voltage drop across the resistor, 12 volts on this side, 11.74 that side. The actual resistance of the resistor, 151 ohms, 149.3, so again, quite closely matched. Gives our cathode current, so the total amount of current running through that resistor on this side, of 79.4 milliamps. and 78.2 on this side. Divide by 2, because obviously it's shared by 2 valves, gives us 39.7 and 39.3 per valve. Times that by your anode to cathode voltage gives us total dissipation for the anode and the screen grid, because obviously they're combined if you're doing cathode measurements, 14.7 watts and 14.62. Now EL84s are 12 watts on the anode and plus a little bit more for the screen grid. So, but that puts us around 122, 121%. So they are a little bit hot, but not excessive for what I would think, for what I've seen EL84s run at previously. Now, the owner has got in touch and said that the previous tech swapped out the 150 ohm resistors for resistors that are 1 to 3 steps higher. Okay, so he fitted 270 ohm resistors each side, and that seems to me like a big jump. That really does. I would argue that, you know, if we calculated our screen dissipation as well, we're probably closer to around 112, 115% on the anodes. So 180 ohms should bring us down cool enough to where we want to be, but not affect the sound too much, as our customer said the 270s did. So do you remember I said in the previous video we're going to try all of them? Well, don't need to try that one, but let's try the 180s, possibly the 220s. So we're not going to try that one, and see where we work out. But yeah, isn't that interesting? Why you wouldn't go to the next size up in your testing, I don't know. I don't know what his thought process was, but those 150 ohm resistors there, I would argue they're one stage too hot for this amplifier. But as we've got the spectrum analyzer, let's fire this thing up. Let's look at it on the scope with the tone control set in the playing position. Have a look at our harmonic output as well as our sine wave output. And then when I fit the 180s, we can compare and see if there is any difference. Okay, so here's the setup then. Amplifier is on, driving an 8 ohm load, which is our 8 ohm resistor up here. We are injecting a 150 millivolt RMS 1 kilohertz sine wave into the normal channel of this amplifier. I've got the tone control at noon and the volume at noon. That's going to be our test point, okay? And that's running, it's pulling 151 watts out of the wall. That's the output sine wave. And at that point, we're doing 19.6 volts into 8 ohms, which is 47.5 watts. That seems a bit spicy, doesn't it? For a 36 watt amp. .36 watts would be 17. Yeah, so that's 36 there. But the tone control at noon, we're putting out, what we're saying, 19.6. And 19.6, 8 ohm column, 47.5, we'll call that. So that's what the output sine wave looks like. But let's look at the harmonic content of the amplifier. Oh God, it's flickering, sorry. So we've got, here's our fundamental. Got quite a weak 2nd, 4th, 6th and 8th harmonics. So our even order harmonics are quite low, but our odd order harmonics are more prominent. So that's what that looks like there. And hopefully you'll focus. And we can use that as our reference. Okay. So now I'm going to increase the value of those resistors to 180 ohms. I'm going to take the bias measurements and then we're going to run the exact same test. I'm not going to move the volume and tone control. I'm going to keep the function generator at the same settings, and then we're going to measure to see if anything changes or what effect cooling the bias off has on this amplifier. So I'm going to write all these measures down. It's actually increased to it's swapping between 18.8 and 19.2. So we'll call it 19 watts, which is 19 volts, which is 45 watts. We'll take the average. Yeah. Okay. I'll note all that down, and then we'll swap the resistors, come back and see how things change. Jim Castillo, I think you've asked questions before, Jim. But anyway, hello, I have a question. I have a Fender Vibrolux Reverb, and the pot, I assume you mean the reverb pot, is a 100k linear. Yeah, B100k, pretty standard for those. Would I gain more range control using a audio log pot instead of a linear? Fenders have this range from 2 to 3 where the reverb is pretty perfect, and anything above that is just surf, isn't it? Yes, you can switch to a logarithmic pot. It's a good mod to do. On different reverb style circuits, it affects it differently, of course. But often all you're doing is that, say, normally your operating point is between 2 and 3. All you're doing is opening that point up. You're still not going to get, still at this point, you're going to get your maximum reverb. This is going to be your minimum, but you've now got a wider control of that gap. So yes, it's worth doing. On some of my amplifiers, I fit a logarithmic pot. On others, I fit a linear pot. Just seems to be what works best for that circuit, etc, etc. Great question, Jim. Thanks for asking. Okay, 180 ohm resistors installed. There we go. Measurements taken. So here's the 150 ohms measurements that we've looked at before. Here's the ones with the 180 ohms. So essentially what's happened is, as expected, the bias has now cooled off to 110% on one side, 107% on the other. Bear in mind that does include the screens. So yeah, but you see it has cooled it down. What's it done to our output though? So before, with the volume and tone control at noon, we were getting 148 watts of power consumption out the wall. We're now getting 142. In fact, it's dropped to 139, about 140 actually. The output has dropped. So we were getting 19 volts AC into 8 ohms, which is about 45 watts. And now we're getting 18.4, which is around 40 watts. So cooling the bias off has reduced the output of the amplifier, as I explained earlier. Has that affected the tone? Well, that's the output sine wave. Here is the harmonic profile. Okay, I'm going to put these up on the screen. So now that the output of the amplifier has dropped, we've still got our even order harmonics that are less prominent than our odd order harmonics. But harmonic number 3 has now dropped relative to where it was before. So we now do have a change in the harmonic profile of the amplifier. However, let me just quickly do something. Let me increase the volume of the amplifier so the output is back to 18.8 to 19.2, back to where it was before. We'll call it 19 volts. And oh look, our third harmonic has come back. So all that's happened is, at the same control setting, yes, there's been a change in harmonic profile because the output has dropped. Increase the output of the amplifier to where it was before, and it's remained the same. So, does bias affect tone? What do you think? Rusty Strings asks, he's just done the same bias adjustment on his own 2061X. This is a video from over a year ago now on the old Marshall 20 watter. Do you remember I added the 100 ohm resistors, screen droppers, on the valve sockets themselves? He wants to know what they were rated at. I think I used 1 watt is there. Ohm's law, easy enough. Joule's law, easy way to calculate it. 1 watt or 2 watt would be fine. You're not dropping a lot of voltage there. You just, enough limitation when you're driving those output valves. So yeah, 1 or 2 watts probably fine. I think I used 1 watt, but yeah. Thanks for asking. Please give this video a thumbs up. All your comments and questions down below. Hit the notification bell. Subscribe if you haven't already. If you want to join the channels like these guys have, that'd be a mega help. I'd really appreciate it, and I will catch you all at the next one.